All right, so on page 79, basic probability. Basic probability. So, we've dealt with probabilities all along. What's the chance that my parents left the garage door open so I could get in when I get home at 2:30 in the morning?
0.
Yeah.
From experience, trust it's 0.
Trust 0, okay.
Can't you just like open the garage?
Yeah, I will say that there was a few times in my high school endeavors that I actually had to sneak into the house through the doggy door.
I've snuck in.
I was just glad we had big dogs. Alright, so how we deal with probabilities, we write it as P at X or P at something. We'll input something in here. Okay, so again, this is page 79. So if we've been dealing with probabilities already, we've been talking about the normal curve. Thanks, sir. We've been talking about the normal curve, and then we figure out the probability of an event happening based on the normal curve. So it's basically number of success out of number of outcomes. Okay, so probability gets pretty easy. So example 1 says probability of flipping a coin and obtaining a heads. If you flip the coin only once, it's either going to land heads or tails. There's always that one kid. Hypothetically, what if it happens on its edge? Then you reflip it. Yeah. So I guess it is the smallest, most minute probability. If you flip a coin and it lands on itself, it's not like flipping that bottle of water and having it land upright. Probability of rolling a 6-sided die and obtaining a 5, it's 1 out of 6. So if these are your outcomes on just a single die, probability of rolling a 5, you would write it like this. So you'd have 1 out of the 6 outcomes, so 1 and 6. You don't have to keep probabilities as fractions. You can make a fraction, or you can make them decimals, just divide it out. Probability a random person will have been born in January. So January has 31 days, so they're just basing this not on a leap year. So probability someone was born in January, there's 31 days, is 31 out of 365. So, so our sample space on any one of those is just all the outcomes. And then we get to my favorite. We talked about this last Friday. And it's the probability of rolling dice on page 80. So those are all the outcome if you're rolling a pair of dice. Okay? So if you wanted to look at example 4, and they say, what is the probability of rolling a 7? What you basically do is just look at all the outcomes there are. There's 36 outcomes from all those dice up there. There's 36 different ways the dice could land. A 7 is the top right to lower left diagonal. So if you count, there are 6 outcomes. So you have a 1 in 6 chance of you rolling a 7. And then if you wanted to do the probability of rolling a 7 or an 11, you know you have the 6 outcomes of the 7. And then the 11 are 2 outcomes. And that gives me an 8 out of 36 chance, or probability. And then your last example, 8.
What up? Happy Friday.
Yeah, giddy up.
Good morning, sir.
We're on page 80. And then, rolling the probability of greater than a 5. So, if you look, the number of ways you roll a 5 are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 ways to roll a 5. So if you want to roll greater than 5, that means there's 26 outcomes. So there's 30 outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's a mistake there. Huh. So, error in the book. Because they want the probability of rolling a total greater than 5, not just 5. It's not 5 or greater.
It's Landon. Did you get swatted today?
Alright. So, our favorite, a normal set of cards. How many cards are in a fair deck of cards, excluding jokers? 52. How many different suits are there? 4. And we have ace through 10, and then jack, queen, king, right? You're like, why did you count aces as the highest? Well, it is the highest or the lowest. It satisfies the 1 or 11. All right. So, 52 cards. 4 suits, where your suits are diamonds, clubs, spades, and hearts. All right. These ones are the black cards. These ones are the red cards. What doesn't make sense?
You'll see what I mean. I'm pretty sure you'll explain it.
Are you on 81?
Yeah, I'm reading example 10.
Oh, we'll get there. All right. So, example 7, probability of selecting a king. Okay? So, just so we know, there's in each suit, so you have 13 cards in a suit. So, there, each of those numbers goes in each of the diamonds, clubs, spades, and hearts. So probability of rolling a king, there are 4 kings. So you have a 4 out of 52, which reduces to a 1 in 13 chance. So if you shuffled this deck of cards fairly and said, what's the probability I pull a king? Oh, it's sweet, 1 out of 13. Well, I pulled an ace.
Oh, dang it.
I didn't win.
Darn.
Okay? This deck of cards is basically the foundation of why our casinos build them big. All right. So if there are 52 cards in a deck, half the deck is red. Half the deck is red, so I have 26. But I want to pull red and a king. Oh, wait. Red and a king. Careful here. Careful. How many red kings?
How many red kings?
Red kings. There's 2 of them. So I have a 2 out of 52, so I have a 1 in 26. So that doesn't say pull in a red or a king. It's I want to pull both the events. I want a red king to be pulled out of the deck. There's 2 red kings in the deck. So you have a 1 in 26 chance of that happening. Probability of selecting a red or a king. So in this case, we have 26 red cards, and then we have 2 kings that are black out of 52. So that's 28 out of 52 probability. You could reduce that to 14 out of 26, which is... they don't have it reduced. So 7 out of 13 chance, reducing the fraction of doing a red or a king. Friends, the difference between red and a king means both events want to take place. So it needs to be a red card, and it has to be a king. Probability of pulling a red or a king. Yes, you have 2 kings that happen to be red. There are 2 kings that are black. 26 of the cards are red. 2 of the black kings gives us 28 outcomes. And your question is, which one? 10? So example 10. What is the probability of selecting a diamond? I was going to try and make a diamond. I can't make a diamond. Diamond and a spade. So you're pulling only 1 card. So you either have diamonds, you have spades, you have clubs, you have hearts. Okay? So a diamond, there's 13 outcomes. Spades, there are 13 outcomes. But these are not mutually exclusive events. They can't happen at the same time. I can't pull, no matter how hard I work, I can't reach in here and say, oh, sweet, I'm going to pull a spade. Is that spade a diamond? No. Oh, sweet, I'm going to pull a diamond. Is that diamond? Is that a spade? No. So there's 0 ways that I can pull both a diamond and a spade out if I only select one card. So that's the probability of that taking place. Example 11. Example 11 says probability of pulling a diamond or a spade. So this could take place. So this is one event or another event. So there's 13 diamonds. There's 13 spades. You have 52 cards. So that's 26 out of 52. So you have a 1/2 probability of that taking place. So watch out for the words and or. And means both events have to take place. Or means this or that has to take place. Okay, mutually exclusive outcomes can never occur at the same trial. The term helps spotlight example 10. So number 10, example 10 is mutually exclusive. Okay, an event, if you're looking for one event to take place and there are 2 different events that you're trying to make happen, if it's an and, it's not going to happen. So if your events are mutually exclusive, your 2 events are mutually exclusive, so you have event A and B. If they are mutually exclusive, probability of A and B taking place is 0, but the probability of A and B is equal to, oh, there should be a B there, is the probability of A plus, boy, I'm screwing this up, probability of A plus the probability of B. So kind of know that when that takes place. All right, that's it. That's all I got for you. So 4-1, you're going to have some fun with this stuff. Basic probability is a really fun foundation. So why don't you try page 195 and 196. See how you do. And again, I will give you half your points back. I'm not going to go over it. I'll just give you half your points back on the quiz from the other day. Deal?
Yeah.
Everyone happy?
Yep.